Question 15. We have a diagram which is declared as not accurately drawn. We have points A, B, C, D, E as follows. We are given two vectors. One of them is the vector A to B, which is 3, 2, which I can represent using this arrow here. And our second vector that we are given is A to C, which is 4, minus 1, which means that this vector A to C as follows is 4, minus 1. Now, because of the fact that we actually have this drawn on a set of axes, I can add more information. I can technically add the fact that this arrow goes 1 down and goes 4 across. So I can technically add that piece of information there. It may or may not be useful. I'm just adding it to the diagram in terms of setting the scene for what the vectors represent. We have the 3 along and 2 up. So this 2 and this 3 are as follows. Find as a column vector B to C. So we need to find out the vector from B to C, like so. In order to do that, so in this case we didn't need the stuff that I've drawn, but it does help to sort of show that the answer makes sense. To go from vector B to C, we basically have to go the opposite direction of A to B, which is B to A, which will give us the negative of 3, 2. And then after that, after we have gone from B back to A, we can then add the vector A to C. So we have plus A to C, which means we are adding 4, minus 1. We simplify the top of that, we're going to end up with a minus 3 plus 4, which will give us a 1. And we're going to end up with a minus 2, add a negative 1, which gives us minus 3. Just to show why that would make sense, as far as 1 minus 3 is concerned, that's a 1 to the right and 3 down, which should hopefully make sense given the fact that we've got this 1 high and 2 high, and of course the difference between 3 and 4 is also 1. So hopefully the visual representation that I drew at the beginning kind of ties into the fact that we know that that there is our correct vector for B to C. For the next part, we are told that BCDE is a parallelogram. We are also told that the length of C to D is twice as big as the length of A to C, and we are trying to find the length of C to E. So, going back to our diagram, C to D, that is this length here, is twice as long as this length E to D. So if we knew what the length of E to D was, we could double it to get the length of C to D. Well, that length of C to D is, the length of D to E even, is going to be the same as B to C. So effectively what we do here is we find the length of B to C, and then we're going to double it as it is the same, the length of B to C is the same as the length of C to D, and then we have the length of C to E is double said length of C to D, or said length of B to C. So how do we figure out the length of this? Well, if I draw my vector for B to C again, the representation I had there of the 1 across and 3 down is very relevant here when you're trying to find the length of a vector, because when you break it down into its vertical and horizontal components, you create a right angle triangle. And within this right angle triangle of width 1 and height 3, you are trying to find the length of the hypotenuse, which means we have a classic Pythagoras question here. So our length of our hypotenuse is going to be the square of each of the other lengths added together, which gives us x squared is 10, which makes x the square root of 10. Now I'm going to leave that in surd form just now, rather than having to deal with the decimal. Although there's only one more step now, we just have to double it, which means the length of C to E is going to be 2 times the square root of 10. And if I then press the SD button on the calculator there, I'm going to end up with 7.07106, so on and so forth. And rounding that to 2 decimal places means that I'm going to end up with 7.07 as my final answer. done.